So here's your journal for today. It's going to get folded in half like a little schwanky book. Okay. So 7.2 quadratics and their zeros. 7.2 quadratics and their zeros. So this first example just says, hey, we write quadratics in standard form. Then what do? We set it equal to 0 and we factor. We solve each factor for x. Okay. Well, what if it's in factored form? And remember, if it's in factored form, I know that looks a little weird right there. If it's in factored form, remember these are already your roots, right? So you don't have to factor it. You just replace the y with a 0 and then you solve each factor for x. Okay. And then I put a note down here that says the roots have the opposite sign of their factor. The roots have the opposite sign. Okay. Don't forget that. So now we're going to do some examples. So step number 1 says, hey, you have to set it equal to 0. So I'm going to get rid of the y and I'm going to put a 0 there. Why do we do that? Why do I get rid of the y and put a 0 there? Well, because we're looking for the solution, which is the same thing as the x-intercept or the root or the 0, and that's where we cross the x-axis. And the only time you cross the x-axis is when y equals 0. That's why we set it equal to 0. Okay? So we have 0 equals x squared minus 7x minus 18. So I'm looking for two numbers that multiply to negative 18, that when I add them, I get a negative 7. Two numbers that multiply to negative 18, that when I add them, I get a negative 7. Negative 9 and positive 2. So that means my factors are x minus 9 times the quantity x plus 2. So my roots or my solutions are what? What are my two answers? X equals what? And x equals what? X equals positive 9 and negative 2. Yes. What does this mean? This is where the graph crosses the x-axis. That's what that means. It's where the graph crosses the x-axis. Okay. Example are we good with this one? Yeah. Okay. Example number 2. What do I have to do first? Replace the y with a 0. I have to replace my y with a 0. So 0 equals 4x squared minus 881. Sorry, I'm using a yucky stylus right now. So when I have two terms, that means I have to use what? Looking for a GCF or dots. Two terms, GCF or dots. Is there a GCF? Yeah, it's not a GCF. There's dots there though, right? Those are perfect squares. What is the square root of 4x squared? It's 2x. What is the square root of 81? It's 9. What do I put in the middle of my factors? A plus and a minus. So what does that mean? Well, that means that either 2x plus 9 equals 0 or 2x minus 9 equals 0. Subtract 9. 2x equals negative 9. Divide by 2. That means that my first answer is x equals negative 9 halves. My second one, add 9. That's 2x equals a positive 9. Divide by 2. That means my other root or solution is x equals a positive 9 halves. So you have two roots, two solutions. How do we feel about those? Okay. Dots are the ones that I don't know why, but once we put a 0 on the end of it, you guys just forget that you can solve two factors. So you either have a GCF or difference of two squares. That's it, right? It's it. So don't forget about that. That's really important. We spent a lot of time on two factors, two factors, two factors. Are y'all ready for number 3? Yeah? All righty. Number 3. Well, step number 1. I have to replace this y with a 0. So I'm going to rewrite it. 0 equals 2x squared plus 17x plus 21. I know that there is no GCF here because 17 is prime. So how am I going to solve this? Yeah, I have to slide and divide. So really, I'm going to rewrite this as 0 equals x squared plus 17x. And 2 times 21 is 42. So I'm looking for two numbers that when I multiply them, I get a positive 42. And when I add them, I get 17. What two numbers multiply together to 42 that pop into your head right now? 6 times 7. 6 plus 7 is 13. So what is half of 6? 3. And if we take half of one number, we have to double the other one. What's 7 times 2? What's 3 plus 14? Oh my goodness. 3 and 14. That gives me x plus 3 times x plus 14. But don't forget, we have to do the divide part. We slid. Now we've got to divide. Slide and divide. So let's see. Does 2 divide 3 nicely? That's got to go back up front. So my first factor is 2x plus 3. What about my second factor? Does 2 divide 14 nicely? Yep. X plus 7. So either 2x plus 3 equals 0, which when I subtract 3 gives me 2x equals negative 3, which means x equals a negative 3 halves, or x equals negative 7. Those are my two answers. Those are your two answers. Okay. Your last example is actually not a quadratic, it's a cubic. We've factored cubics before because if we have a cubic, that means that there's a GCF. So 0 equals, what is the GCF in this? It's x. We're going to take an x out of everything. So 0 equals x times 7x squared minus 45x minus 28. So I'm looking for, oh goodness, I'm looking for two numbers that when I multiply them, let's see, 7 times 28 is, anyone? Well, 280 minus 196. So I'm looking for two numbers. So I have x times the quantity x squared minus 45x minus 96. So I'm looking for two numbers that when I multiply, I get 196. When I add them, I get a negative 45. God bless you. So let's figure out what those two numbers are. And then we're going to have to do some dividing. So 196, negative 196 divided by x. It's going to be a big and a small number. What about 4? There you go. Positive 4, negative 49. Positive 4, negative 49. That means I have the first factor of x plus 4, the second factor, x minus 49. But don't forget, we multiplied. So these two factors have to be divided by 7. So my final answer, like factor wise, is x times, well, does 7 divide 4 nicely? No, so put it back out front. 7x plus 4 times, does 7 divide 49 nicely? Yes, x minus 7. So what does that mean in terms of my answers? Well, my first factor is x. So either x equals 0. My second factor is 7x plus 4. So 7x plus 4 equals 0. Or my last factor is x minus 7. So x minus 7 equals 0. So that's just it. X equals 0. For this one, when I subtract 4 from both sides, I get 7x equals negative 4. Divide by 7. X equals negative 4/7. This last one, add 7 to both sides. X equals 7. So these are your 3 roots. These are your 3 roots. I put a note at the bottom of your paper, which I think is extremely important, and sometimes you guys forget it. It says the solutions to a quadratic equation are the same thing as what? What's another word for solutions? Roots. What's another word? And another word? Zeros. And then I'm going to write a little, because you have 2 lines there. And I'm going to put it's where the graph does what? Yes, crosses the x-axis. That is so important. That is so important.